Hello everyone, welcome to another stream. How we doing? So last stream we started on the texture viewer. So now we can now press F9 and open up this and it shows us all of our textures that we have in the game right now. We can then select a texture or we can search for one and it's fuzzy search basically. Then when we click on it, we get the name here and we have a split view. And on the right is where the texture is going to be. So where I want to start off this stream is I want to get all of the information about the texture in the left hand side panel. And then we're going to go ahead and get the texture being viewed on the right hand side. So yeah, it's going to be good. It's going to be good. So let's start off by just getting all the data in that panel. It's going to be nice and easy. So here where we do the split view, split area, if yeah, so this is the box, the left hand side box. So what we need to do, we've got the resource here. So we need to do it's the internal header, yeah. So all the information is in here. So we can start by literally just displaying it. So all we want to do is say right, this displays the name. So we cut again, and we're going to display in here the. So we'll probably have like a buffer or something where the stuff lives. So we'll say, I don't know, 128, probably plenty, maybe even just 32. Well, no. So we'll smprintf into that buffer. And we're going to be putting in the dimensions. So I guess there is a storage format as well. Yeah, we've got names for these guys actually. That's probably public in the public header. Yeah, so just got a byte per pixel. We haven't got a names array yet. Hey Flappy Runner. Is this Lazy Vim? I'm not sure what Lazy Vim is. It's basically NeoVim. It's awesome. Yeah. Not sure what that is. So here we just want to simply display the names. All right. I see. So it's a way of setting up Vim. Okay. Now I used TJ's Kickstart because I wanted to try out all the NeoVim stuff that people are all using, and I came from kind of like a vanilla Vim setup. It's got some useful bits, but also sometimes the more dumb Vim setup is just better in some ways. But yeah, they've got some pros and cons, but I haven't bothered changing my Vim for a long time. If you're talking about the theme, so this is set like, well, were these relative line numbers, or are you talking about some colors? Basically, if you're interested in the theme, it's kind of a custom theme based off of another one, basically. So I saw a theme which was like mostly there to what I wanted, and it made it even more what I wanted. But yeah, line numbers aren't really part of that theme, I don't think. Maybe they are. Um, yeah, I get what you mean. Like it's dead quick and fast. All the NeoVim stuff just adds all this lure, and which it can be nice, some of the functionality, I'm not gonna lie, but it just adds so much more stuff. It's so much more bloat in a way. Yeah. I don't necessarily need them to either. If I was working on a big project, like a large code base, then probably. Right, that would be helpful. Most certainly. Right. So here I can actually do a string. And we're going to put in resource sampler, texture dot sample format. Ooh. Don't know why I said string. What I mean is sample format. So put that into buffer, and we display the buffer out here like that. Awesome. So let's just see how that looks, and we can always, I want to see how that looks because we did one without any padding, I think. Right, a bit big. I can't really see anything there. Yeah, this kind of suck. I wonder if we can make that smaller. What's in this node box style? Can I say 14 on that? Nice. See, I forgot, it's not going to give me pixel perfect format, I think. That's good, I like that. It's better. Although having this limit here on the slider is stopping me from seeing everything. Yeah. The only thing I don't like about NeoVim is that I can't just do my Vim and use it. You can, but you have to convert over to the Lua one, I guess. If you want, yeah, that's true. Yeah, if you want to use all their stuff, yeah. And if you want to use this vimrc purely, you probably have to do like a Lua script from within it or something, yeah. From what I remember. But yeah. It's weird. It's just like, it's like C++ to C. These things just come along, do something completely different based on something, based on an original work. It's just weird. So how big's this font again? I think it's 10 pixels is perfect. That's why was it 20 before? Yeah. So if we put down to 10, that'll draw it pixel perfect. Right. I'm okay with that tiny font. I'm not sure if everyone else is though. But this is the way. It makes stuff viewable. There's so much spacing between that. I thought I got like no padding in that. Like, what's going on? Oh no, it's just we cut. It's the amount that we cut by. Right. There you go. So then we can drop that all. What do you mean, why not Linux? We are running on Linux. KDE. Um, music is quite loud. I thought the music is fine, right? It's down here. Huh? No, we are running on Linux, right? It's louder than the microphone? No, what's going on then? Wait, let me mess with something. It can't be louder than the microphone. Something's up. You have to do this sometimes. Right, is that better? Yeah, it's been the same settings. Yeah, I don't know. Yeah, it's always been fine. But yeah, thank you guys. Hey Cav, hey Glorissa. How you guys doing? Yeah, I specifically tuned it to be a good volume. This is about 35 decibels, or negative 35 decibels. And here we want to get to the orange. But yeah. But yeah, Flappy Runner, we are running it on Linux. I don't know what the issue... I'm not sure what the question is there, basically. Right, so we've got sample format, storage format. Yeah. So we've done these two parameters now. Let's do dims, dimensions. So it's like an XYZ. Right. I could put it as width, height, whatever, but let's just cram it all into one. See how it goes. Resource texture dims.x. YZ. And let's go again. So a base MIP level, MIP levels, and array layers. So these we can stick on one as well. So we'll do something like MIP. Oh no. We just want to say MIP levels. Array layers. You know, I've started to like the name array slices instead of layers. Because slices, that's what you call and a 2D image, a slice. So, rather than a layer. But I can always change it. But let's see how that all looks, because that's all of the properties, attributes of the texture. So we can click on it, and it's all here. It is a bit small, not gonna lie. With this format thing, I think what we can do is have a short strings name. So we'll do two versions. One's the long one, one's the short one. And this would then be regarding like the sound quality. I noticed when I was doing some editing the other day that there is a slight bit of echo in this room. So what I'm going to try and do is I've got some sound dampening panels coming, so I want to stick those up, and also going to stick this green screen up on the wall and hopefully improve that quality as well with a green screen. So yeah, hopefully that's better, because I know my voice and the way I speak isn't necessarily the clearest. I do like mumble a lot. So hopefully that sort of helps with that situation. But yeah, see how that goes. Doing fine. Did see your last Game of Legend recap? Seemed quite tired, but it's nice to have it. I'm quite tired, but it's nice to have it. Yeah, I'm. Yeah, I've been tired the past couple of weeks. Bit difficult to catch up on sleep. But yeah, I think things they'll sort themselves out. And also, by the time I stream in the evening, I've already had a whole work day as well. So, but yeah, hopefully we'll get better soon. Yeah, glad to hear you're doing fine. So yeah, what did I change? I did the short versions, yeah. So now we're done the short versions. Can I make the text height back to 20? Maybe we'll just do 15 or something, but then you'll get like half pixels. No, they're not the short names, because I didn't change it. Right. If so, we might increase the size that we can drag the this out to, because it would be a bit. So we should align everything. That's another thing. Everything should be aligned. Yeah, so everything should be aligned, so we should just increase. So we should probably also increase this to be like, I don't know, maybe we shouldn't have a cap, right? Just put it as infinity. Put that to 0. Then start the cursor off at probably 500, maybe. And then we should be able to But I can always move it around. Yeah, I don't know. Maybe we should call this... Maybe we should try and shorten these names a bit. Because it does take up a lot of real estate. Or we could just decrease the font again. But it won't be pixel perfect, but that's okay. Bit ugly though. 16 is a bit bigger. Do you like the taste of Coke Zero? I had a discussion with somebody who's arguing that Diet Coke shouldn't exist. They should just drink Coke instead. What, you mean Coke Zero instead? Because that's the zero sugar one. Yeah. As a Gen Z, that is a valid thought, right? But as a millennial, Coke Zero came around first. Oh, sorry, not Coke Zero, Diet Coke came around first, right? So as a millennial, Diet Coke came in and it was really popular. And if you are in the games industry, you'll know that basically it's a lot more popular to have the it's not more popular to have Coke Diet because it was just stocked in the fridges all the time. But yeah, Coke Zero is more popular with the Gen Zs. I quite like. I prefer Pepsi Max, but we just got these on offer, so Coke Zero it is. Yeah. Yeah. Also, as well, when you drink like standard Coke, you just get all that sort of feel that sugar all in your mouth, all over your teeth. You know, bit much. Yeah, I think that's all right. It's a bit better. Thinking maybe I can shorten some of these names, but maybe that's all right. Sample format. If I get rid of the vowels. I don't know, it just looks so ugly. But that's a bit better, it's less and less characters. 3 less characters. And this could just be MIPS. I don't know if it's just gonna be unreadable now. But I guess there's 3 less characters. It is something custom, so I just have to understand it and then that's fine. Much more real estate there, I guess. It's just sample and storage format. They're ugly. If we could bring those formats down, if I could just call it formats and combine it into one, then maybe that is another way. So sample format first and storage format second. And that means all these can come down by a lot more characters. And then we can go back to being like, hey, this thing can start off at 300 instead. And then you got a lot more room on that right hand side. No, not quite. We still probably need it at 500 or whatever. Maybe 400. Yeah, this is Stone Rebel. You should give Stone Rebel a listen to. He or they, you know, a group of people, I think they release stuff like every month. So if you want to listen to music like this a lot, recommend giving that a listen to. Right, so this is good. I like where we're at here. Oh shoot! What? Sorry, I put F5 in there like a melon. Right, that's good. So we've got some information in here about the thing we've clicked on. It's alright. What else do I want in here? So go back to the super lovely texture viewer. The resource viewer documentation. So I've got the texture spec in there now. We can tick that off. We probably want to have some viewing options. Let's start off by let's put a separator in. We don't even really have separators. We'll do a box. So we can cut top, put box in. Cut 4 pixels, chuck a box in. That's our separator. Then we want to put some viewing options in here. So we want to be able to select a certain MIP or array layer. So I think we're going to have like a text. Wait, input box. Input. Wait a minute. Let's open up the header because it's failing to find it, even though it's apparently using Clang underneath, which it obviously isn't. Well, it is, right? Because it's all showing up now, but still. Yeah, I'm including the UI header here. It's weird. Anyway, so we can say, hey, I want to input a U32, pass in the rectangle, and then we pass in the value we want to change. Where's... Oh, that's a bit annoying. I don't have one with a bit of text. Do you not have ones with bits of text? So we have an input text box like for actual text, but not with text alongside it. But there is so many configurations. It might be a bit of a pain, but still. Yeah, because we have it here with a radio button. Where you can put a string in. But then how many configurations would you get? And it would be a bit confusing with this text thing. For now, because I want to make progress, we're just going to make our own inline. We'll put to do label by it. Yeah, so basically you cut top. On a... So we want to have a text field with rectangle B, and it's going to just be like MIP. This is the one that we're viewing. We should probably have another string actually to say viewing options. I don't know. Let's just say MIP. Pass in the no box style. Then next to it is going to be the input box. What goes in here is another B rectangle after we cut again. We'll get the numbers correct in a minute. B rectangle, then the modifier and valley. So this has got to go inside the... Let's close that. Move that along. So in the... There's some texture viewer state here. We want to, I guess in the tab, we want to have the MIP level we're viewing and also the layer, the array layer. So that would then be tab MIP, right? Very nice. So what sort of numbers do we need? So we need probably, so that's 16 pixels each, 4 characters. We're gonna have probably 5 characters, so maybe 128, 8 characters maybe, or maybe it's 96. Yeah. Okay, so do that again. And this one's going to be for the layer. You know, maybe we join them up on the same... No, maybe this is fine. This is the array layer. Oh shoot, what's the size of this box? I think it's just the rest of the... You know, it's just the rest of it. Maybe just put A in there. Yeah, and then we say array layer. Cool. So, wait a minute. Alright, let's get this going. So if we look at that now, we should have a couple of input boxes in there. I don't see anything clearly. That's weird. Oh shoot, that got cut way too much. That's going to cut to the left. That's why. Right. These haven't got the right style, so they're not looking good. But it's okay. Let's change the style to box style. Let's see those in action. Right, clearly... Yeah, clearly not enough room on the height there. So let's make them 40 instead. Where's the split thing? Right, these are kind of in the lower left now of it. I guess it's okay for now. We can just put in a number. And these should have like a min-max. I guess I manually clamp the value afterwards. I don't remember. Yeah, so the input allows you to put whatever you want in. Yeah, that'll be right for now. So let's put what I want in. And we're going to remember to clamp it. So tab mip equal the clamped value between 0 and, wait, mip 0 to resource texture mip levels. Yep. And then the array layer here. Nice. Cool, so if we put anything crazy in here and then click out, that should have updated. Not gonna lie. Oh. Alright, let's change copy paste error there. Yeah, great. Okay, so puts one in. Good. So they get clamped now. That's fine. So, yeah, we want to clamp to -1 of that. Okay, so that's looking okay. I think this one needs to be a horizontal center. So we need to horizontal center, sorry, vertically center of B. With what's the height? It's 20 pixels, isn't it? Yeah, it's the no box height dot texture line height. That's it. So we try that. That should then center align these. Excellent. So they're now aligned rather than being the lower left. So that's cool. So we can select a MIP level to view at least. That's nice. All right, anything else on this left-hand side panel before we move on? So the separator wasn't showing up. I put it in. I did a cut. Only 4 pixels though. So let's do 8 pixels. I'm expecting to see something. Right, I'm starting to see something now. It's because it's got the roundedness on it, is it? It can't be. Right, we'll take that. Yeah, it says a separator now. So here's the stats. Here's the viewing options. I'll have another one where all the yeah, that'll do for now. Just needs to be functional first. Okay. So we've got some of these viewing options. Array slices and MIP. We've got a separator between these. But we haven't got the separator here between this list of shaders and that. This will come soon. Yeah, we'll do that after we've got the texture actually being viewed. So, right, that's a good place to make a note about. Okay. Okay, so let's put a marker down. All right, let's recap what we've just done. Okay, so now we build up the texture viewer. What we've added is when we click on a texture like a surface, in the left-hand side panel now we've got the name, the two different formats, the sample format and storage format, the size or the dimensions of the texture, how many MIP levels and how many array layers it has, with the ability to select a specific array layer or MIP level. And notice here when I type in a value and it's too big, it will clamp it to the min and max value. So this means now we'll be able to sort of see the information and also change which MIP level we are an array layer we're viewing at least. So this is enough information or enough of the left-hand panel that we'll need for now before we go ahead and view the texture on the right-hand side. Cool. I think that's okay, good enough. Let's. Oh no, I didn't talk about the. Right, let me drop another. Let me do that again, and then we'll just go over the code. Right, so we just got the left-hand panel done. So if we build up the texture viewer and click on a texture, we'll see that there's this left-hand panel and it's now got like the name of the texture, the two different formats. One's the sample format, one's the storage texture format. And it's got the dimensions of the texture as well, along with the MIP levels and array layers. And these two are input boxes for when we want to view a specific MIP level or array layer. So now we have all the information and the viewing options that we need at minimum to start viewing the texture, right? And notice when we put some values in here, it clamps it so it doesn't go out of bounds. So let's take a look at the code. We've effectively, we've got if we've got a texture to view, we have the split area. We've got this is the left-hand side box of the split area. And we get the resource that we're viewing. And essentially we just keep taking from the top. Here's the button. Here's the name, format, dims, MIPs, and array layers. We just use a bunch of text widgets and snprintf into a temporary buffer. And then we have a box for the separator for the options. And we then put in the MIP level viewing options and the array layer viewing option as well, which is just a input box. I don't have combo boxes, so we're just using input boxes for now. And they'll probably be fine. And we just clamp the value here so that they don't go out of bounds. So there's still some missing things from here, like the hover pixel and reinterpreting pixels, but these things are nice things to add when we have when we're actually able to view the texture. So that's what we're going to work on next. Cool. So is that good? That was good. So now let's actually work on that texture. Viewing portion of it. So how do we? So this texture viewer will be able to select specific shaders that are written to the texture and view it sort of just as it's been written to. And so so because we want that functionality, we need to basically be able to take a copy of the texture and store it in a temporary texture. So that's basically how the system works. So we need to define a resource. Maybe it could be part of the built-ins. It doesn't have to be though. Okay, when you initialize the GPU system, maybe it can. It might as well be a hard-coded ID. Where's the shared? Right. So we'll just do a hard-coded resource index. We'll call it texture viewer. Texture viewer copy. It's the copy of, yes, it's texture viewing basically. So I guess we'll just initialize it here. It would. So I guess we'll initialize it. Initialize the texture viewer copy. So effectively, we want to have some form of max resolution in texture copy. So probably 4K is just enough. So maybe what we do is we store somewhere sensible the max texture resolution. Maybe we can store it in here. GPU max texture dim, and that's just 4096. So when we initialize a texture, any texture, we want to make sure that we core assert that all dims are less than or equal to that. So we just want to say, you know, texture must be dims are blah 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 dims.x, dims.y, dims.z. So yeah, cool. So that's in there. We've got to do it for the texture view as well, and we kind of also have to do it for the swap chain. Within the swap chain, that's questionable. Oh no, not texture view. That's fine. What about the swap chain? The surface. Are those dims like, yeah, they're hard coded. We need to make that. Yeah, I need to think about that one. Because we don't do resizing yet on the swap chain. Hey, oh, I forgot to pronounce your name. Remind me again. Ants? Yeah, that's it, Ants. Welcome back, Ants. How's it going? How you been? So when we initialize the GPU system now, we've got this texture viewer copy, and we simply just put in the max size. So texture dot, so it'll fit in all these bells and whistles. So dims equals, so it's just gonna be a 2D slice that we're viewing. So we're just gonna essentially put GPU max texture dim. I'm gonna do that for the X and Y, because we're only gonna be viewing a 2D slice at a time, a bit like they do it in the RenderDoc application. So when we might support viewing multiple at the same time, like MIP levels, but that'll come later if we do it. But let's just get the. So on the dims, sample format, I guess would be. So we're sampling from this texture. Are we going to sample from it? I guess we want it to be RGB. And storage format. So I guess the idea is we'll manually pack RGBA in there. We'll manually pack RGBA. Yeah, and then we'll just display it as a normal texture in the user interface. So we need a shader to convert copy from the text we want to look at, do all the reinterpreting of the pixels, and then just simply display it. That's a nice way to do it. Where am I going to now? There's, oh yeah, I want to view this. So we got base MIP, yeah, those are quite easy. Base MIP and, right. So base MIP is going to be 0 because it's not a view. MIP levels is always going to be 1. Right, there's like no MIPs basically. And then array layers 1 as well because there's no array layers for this thing. So it's basically a 4K texture squared. Like a proper 4K texture squared. And here's the texture viewer copy. Now, the texture viewer copy is going to show up in the texture viewer. We don't want this to show up in the texture viewer. It's a bit weird, right? Texture 2D. So we need to make sure, oh, for crying out loud. Yeah. So we have to make sure we don't end up accidentally oh, these are internal, eh? Interesting. Nice. Texture viewer copy resource ID. Cool. Rightio. So we have to make sure that we are not trying to view this once. So when we go in our texture viewer UI, when we filter through all of those textures, you have to say if res_id dot raw equals the resource ID of the copied texture, continue, right? We don't want to have that one selectable in there. Okay, so now we've got that texture there. It should be initialized. Let's just try and run it and see what happens. Oh wait, that's his indirect buffer. It's not you. Alright, let's give it a run. Got a validation error. Maybe the texture's too big. Just gotta wait for it to do a address to line about 7 times across a massive shared object file. Right, here we go. Right, so try to allocate from a heap. What is that, 8 gig? Why is it trying to allocate 8 gig? Oh yeah, that'll be right now. No. Yeah, so that's the size of the heap is 8 gig. Right, okay. Good to know. That's the device local heap, probably. That's a bloody big number. So something painfully wrong happened. So, oh, that's why. Try to initialize it as a, yeah, that's not good. As a buffer, but we should be putting it as a texture. Right, so now it's all initialized. Excellent. Without any problems. So now what we need to do is actually copy to it. So I guess I'm just going to recap this, and then we're going to copy to via a shader. Because if not, I'll forget some things. Okay, so we've ended up making a new texture resource, which is going to store the copy of the texture. So it's going to be a texture 2D. It's going to have a resolution of the maximum resolution that we support. And the reason why we're going to only view we're going to view the texture into a separate. We're going to copy the texture we want to view into a separate texture. And the reason is because I need to redo that. It's not too much stumbling. Yeah, let me think about some words a bit. So yeah, we want to copy into this because when we reinterpret in pixels, and we want to just simply use the UI library to display this. Yeah, something like that. Yeah. Okay, let me put another marker down instead. Right, so we've gone ahead and made a new texture resource, and we're going to be copying the textures that we want to view into this separate texture resource. So it's got the size of the maximum size of a texture can be. So it can fit any texture in there, and it'll only be around for debug purposes, so we don't have to ship with this. But essentially we want to view a texture, but only like a certain MIP level or a certain slice, and we want to reinterpret the pixels and view them differently. So we're going to be taking the texture from a certain point in time in the frame, copying it to this texture, and then while we're doing the copy, we'll be changing it to a certain RGB color that that's reinterpreted the pixels into something sensible and easier to view, if that option is enabled. So something else that's obviously popped up is in the texture viewer, we don't want to be able to view this texture. It makes no sense. So obviously when we filter out the texture IDs that we want to, that are controlled by this filter text box, we also include in this loop, when we iterate over all the resources, if the resource is this texture viewer copy, then we're just going to skip those. So now that we have this texture resource copy, we're going to go ahead and actually copy our first texture into this resource. Okay, that went much better. Let's go ahead and do that. So what do we need, right? We obviously, how you fix everything with GPUs is you just add more shaders. So we need to add a shader. Now, I don't really have, do I have a shader? Right, I have a shader header file. I guess we stick it in here. So I already got this GFX shaders, but it shouldn't go in there because that's the game graphics shaders. But this is like a header file. It's fine. It's included in here only, I think. So yeah, we definitely want to say, right, yeah, okay, I've not defined HCC. This is header file meant for shaders only. Excellent. So I guess we can just stick a compute shader in here. So we're going to add Let's get our bundle constants. And let's get a compute shader. Let's find a decent one. Oh yeah. So here we go. Gotta just quickly get all the bells and whistles. I need to include standard int ball and all that. Right, good. Right, so we've got less errors now. So the bundle constants that we need is, this is the texture viewer copy compute shader. So we know the destination texture, so we don't really care about that. But we don't know the source. So we need a texture 2D, which is, we need E32, which is a resource ID. But we're going to have to pass in some information to know what type it is. So actually, we don't really have that GPU accessible right now. So we need to move. Right, this is interesting. Yeah. We need to move this into the shared section. So we can know if it's texture 2D, texture 2D array, or texture 3D. So in the shader code, we also need GPU resource type. Like so. So now we're going to call this shader GPU compute shader. GPU compute shader texture copy. Texture viewer copy. And we're going to put in here texture viewer copy. Right. So from here, we also need the dimensions of the... Okay. But if you're doing texture 3D, I guess you do slices. So you have a 3D texture. Or maybe MIP, then layer. Maybe you can treat 3D as like just a bunch of array layers. So you probably need like the MIP, the layer, and then you'd also need like the resource, MIPS count, array layers, something like that, right? So you'll be able to do the bounds checking there, maybe for safety reasons, just in case the CPU does something wrong. So we treat... Yeah. So we'll dispatch 8 by 8. And the dispatch index will give us a coordinate. Well, not necessarily. So I guess let's just delete all this because it's a load of rubbish. We're going to go ahead and switch on the resource type. And what we basically want to get is a f32 times 4 back. We want to get some kind of pixel back. So I guess we should default initialize this to something sensible like 0001 for an opaque black pixel. Then we want to do a conditional on these guys, and here we can then cast our 32-bit integer into a texture. Texture 2D. Now, we don't know what right, how are we viewing these textures? No, sorry, how are we loading from these textures? We're doing like you're doing like a load, maybe. I was thinking, yeah. So I think all my textures are. Yeah, I think all my textures are just 32-bit integers for the pixel data. So maybe that's safe for now, just to do a load, pull it out. And then maybe in the future, if we add a new texture, like a 16-bit texture, maybe that's another option. Yeah. Okay, so I guess we just get the pixel out here. Because we haven't really done anything different yet. So we're just going to cast the resource ID into that. Then I need to do like a load. So load texture 2D. So you put the resource ID in there. And then followed by the coordinate. So the coordinate in the texture 2D is simply dims. Sorry, no. SV dispatch index dot xy. Now, this gets you back a pixel, but the problem I have is the out of boundsness of it. So I guess we just check it up here, like we do in the other ones. So we just say if any of them, of the dispatch index. The problem is if we view different slices of the 3D texture, then that won't be good. But I think this is sensible enough for now. Or if we view the whole, if we copy the whole texture and all the MIP levels, this will have to change as well. This will do for now. Right, it's done. Okay, so we're loading in the texture pixel there. For the array, it takes in... So we need to make a new coordinate. So the coordinate here is SV dispatch index X, SV dispatch index Y, followed by the layer. So that goes into there like that coordinate. Then yeah, 3D would be the same thing. Excellent. So then we should probably do the checks here too, where we say if BC MIP is greater than or equal to BC resource MIPS. This should never happen, but it's just debug code anyway, and it's better to be safe than it crashing. Okay. So now that we've got the pixel, we need to store it into the texture. So we've already got, we want to make a read write. Read write texture. And this is going to be this hard-coded index here. So this is the destination resource ID. Or destination texture. Cool, so this is implicitly cast into that. So now what we can do is we can store our pixel in there. Now, the pixel really should undergo some conversion. So what we should probably call this is color. We're going to unpack this into a F32 times 4. Then here we're going to put the to-do reinterpret pixels as a color. Based on viewing options. And then we want to then store into the texture 2D as E32. So I'm going to pack the color packed. So we'll pack it back down. And then we'll store in the destination texture as color packed. Right. We need the coordinate. So the coordinate would just be SV dispatch index. So we might have to clear the texture as well. We'll think about that one. Or maybe we'll only view a certain UV range. No, clear will probably just be easier. But yeah, what's going on here? Oh, .xy. Done. So this should be the basis, the basis of the shader. Again, if we end up having any U16 storage textures or whatever, we shall have another if or switch statement, right? But for now, this should be good enough, and we'll be adding more stuff here. Right, so I think I might document this now. I don't know, let me get it compiling first so there's no obvious mistakes. For crying out loud. I had this issue in the Switch. It was very weird. Apparently, yeah. What was that in the HCC that we discovered the other time? Fix switch where condition is a constant. Let's see if I can look into that. So for that as const. Yeah, it doesn't like it. So I need to strip the const away. Or something like that. I think we can fix that quick. AST switch. The condition expression is here. It generates the statement block. So let's have a look at that. I guess there's a case statement. Case statement. Nope. This is it. No. Right, keyword case. So it gets the expression. Ensure readable. If it's not constant, it must be a constant. Ensure type compatible. This is it. As an assignment. Should mutate the. Yeah, maybe it should. So it should be like assignment in a way, but we need to strip away the const on this thing. So there's a way to strip qualifiers. And there we go, that fixed the issue. So here we still got the const, press F5 now, and that'll work. Okay, so yeah, when we commit this, we're gonna need to recompile the Windows version as well, because yeah, this is gonna break the build. We don't have the updated executable. Oh shoot. Yeah, I guess we'll leave it as const. So that bug never comes up again. So we build a new release package. We'll grab the optimized version of the compiler so we're not getting slow builds. In the wrong project. Build HCC. Drop in the third party folder. And voila. So now if we build this, we shouldn't have any problems. Nice. Type mismatch. Does not implicitly cast. Oh, right. Okay. 2D array. And 3D. The error message is a bit off, but it's alright. Unspot intrinsic type. What's going on? There's no U8 in there. Oh, is this defined as a U8? It is, isn't it? Yeah. So it's saying that there's... Yeah, it's a U8. So I don't have those in shaders. So we shall do this instead. Because it's probably useful CPU that it's got that. Alright. Hit compile. And voila, there we go. Awesome. So now I've got this, I want to do a recap. Yeah, so where am I going? Right. Okay, so let's put a marker down. Right. So what we've gone and done now is we've moved this resource type from the CPU header GPU H into a shared header file which is shared between CPU and GPU. So now we can know if a resource is like a texture 2D or texture 2D array or texture 3D. So now what we've gone and done is written our shader, which does the copy. So this copies the texture at that certain point in time into the texture viewer copy texture. So the input parameters that are uploaded via these push constants is the resource ID that we want to read from, its resource type, how many MIP levels and how many array layers, and it's the size or the size of the texture or the dimensions, and the, I need to do that again, it isn't as smooth. Yeah, still one more time. Okay, so what we've gone and done is moved this resource type from CPU code to code that's accessible from the GPU and CPU. So we moved it from this gpu.h into gpu.shared. So now on the GPU, we can know if a resource is a texture 2D array or a 3D, which is helpful for our texture viewer copy shader. And it's just a compute shader which launches across the whole of the source texture we want to copy from. So when we are trying to read it from a certain point in time on the frame, we inject this shader, or we're going to inject this shader, and it's going to copy it at that point in time and put it into the texture viewer copy. So it's got a few parameters in the push constants, like the texture it wants to read from, the resource type, the number of MIP levels, array layers, the dimensions, the MIP level, and the array layer. So we do some basic safety checks just in case if we go out of bounds on the texture by the 2D coordinate, the MIP, or the layer. We're going to just return so we don't crash. And then we check the resource type. If we're a texture 2D, we load from that pixel coordinate as a texture 2D. If we're a 2D array, we make a coordinate out of the X, Y, and the layer parameter which is passed in. And we load from the texture 2D array. And then 3D is the same thing as the 2D array, but we do the 3D load instead. And the 3D coordinate comes from the layer. So we're going to leverage the array layer for 3D textures so we can see through all those different layers that way. Then after we get that pixel, we're going to unpack the pixel as some color. We're going to reinterpret the pixels potentially based on our viewing options. So we still need to do that still. And then we pack the color back and we store it into the destination texture. So now the user interface can literally just display this texture viewer copy, and it should be, and it's just relatively straightforward to do that, which would be nice. Yeah, so let's go ahead and get this shader plugged in and get it copying something. I don't think I missed anything there. I think that's basically it. So we just want to view the texture at its latest point in time. So at the end of the shader, end of the frame. So we just submit. We're just gonna throw it in here. But it's not necessarily where it's gonna always be. So we're gonna make a new function. This is, so here's the texture viewer stuff. So we'll move some of this stuff into its own section because we're starting to accumulate things. This is going to be GPU texture viewer copy dispatch copy. And we put in a void. There we go. So we look out for, I guess, command set. Look for that. Yes, above here. I get the header as well. So basically we're going to go into where we dispatch one of our other shaders, and we're just going to grab some things. We don't have to type it all out, and we'll just get everything initialized. So, so we want to get our current tab. So I guess we do something like this, just in case we go out of bounds. Got a nice bounds check in there. So GPU compute shader, texture copy, bundled constants. So now we're going to fill in all of these things with the settings that we have from the texture viewer itself. So BC dot, and well, I guess maybe what we do is we say if tab dot or tab deref reside, if this thing is null, right, then return, right. So it's a nice bit of safety there. I want to grab the resource, so the GPU resource get, so I get it from the pool, and then we want to place the resource ID in here, but not necessarily this one. We need to turn into a resource index. So I should probably call this a res index instead, because ID means it's got the counter bits in the higher bits, whereas an index, yeah, it's just an index. Rightio, what is going on here? Oh, this is not shared. Okay, we need to move this into the shared header file. So this is accessible from CPU side as well now. Okay, so resource type, this is going to be equal to resource type, like so. MIPS, resource texture MIPS, MIP levels, resource texture array layers, dimensions resource texture. Dims.xy. Now we have a bit of a thing here. If we're texture 2D or 3D, we need to behave a bit differently. So we've put our selected MIP level and array layer in there as well that we want to copy out. That is from the texture viewer itself. So, yeah, so we're texture 3D. The number of layers is dim z, right? So I guess here we just say if, or maybe we do a bit of a switch. Resource type. And here we're going to say, well, if you're a GPU resource type of texture 2D, or if you're an array, or if you're 3D, we shall treat you guys differently. And what we also want to say is default core abort. And we want to say, you know, unhandled. So if we ever get to here, it's going to actually crash, and it's not going to be allowed to continue because the shader code doesn't handle this. Well, I guess it does handle it, but yeah, it doesn't implement it, if you will. So what we need to do next is go ahead and, so that's just for 2D. 2D needs that way. 3D wants, actually no. 2D and 2D array are the same. 3D wants the array layer to be, yeah, that one. But the number of array layers is resource texture dims.z, and that's the only difference there. So maybe the rest, I guess we can always change this later on. All right, good. Nearly there. Meatball 1, man, it's just 3Ds. Yeah, 3Ds. This is the way. Can you imagine if you wanted a 4D? Yeah. I can't imagine 4Ds. It is too much for my brain. Too much. How's it going? What have you been up to, Meatball? So we need to put some explicit sync code in, because it's what we do. We're going to read write to the texture viewer copy res ID, and we're going to read only from the tab resource ID, and then we're going to launch this shader, GPU compute shader, texture viewer copy. How many of these boys are we going to launch? Well, we're going to launch a divided roundup of their dimensions along the x divided by 8, because our local size is 8, and the y by 8, and then 1 along the z. And then the size is of BC. And voila. So what we need to do now is plug this into that lovely frame submit. So the frame submit, we'll plop this in here for now, but we're going to be moving that to a proper place soon. So yeah, that's cool. Next thing is we need to probably actually view the texture, but I guess we want to make sure that we're actually copying everything okay and doesn't crash and burn the GPU. You're doing okay, awesome, good to hear. Oh, here we go. So F9. Click. It should be copying a texture right now. And there it is, copying a texture. Bum 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 bum. So it's actually calling it. But we can't see it yet. So the next thing to do is actually put it in the UI. Nice and easy. So we're gonna look for texture view UI. On the right hand side, we make a box. So here's the split view. We put a box down for the right hand side. I guess we'll keep that box there. So we're gonna make a start and an end. Chuck in an if just in case it's not visible. And then in here we're gonna put an image. And the image is going to be... So I need to initialize a new image. Oh my days. Because they take image IDs. Oh. With a UV coordinate. Alright. So we'll put in the rectangle. We'll put in the image ID, GPU, texture viewer copy image ID. We need to make that. Followed by the style of box style. Wait, no box style. A good combo. Hey Kappa, Henry, what sort of game do you want to make? What do I want to make? I want to make a RPG. So I want to try and make it so it'd be like procedurally generated world or set of worlds, and it's gonna be, there'll be a start. There's like basically you can have tons of random different starts, but the core story before the game is the same. But you have a bunch of different starting positions and different people you pick up from. So it's gonna be like a simulated world that kicks off. You'll start off as a person, and then you've there's an end condition to the game, and you'll have to play through the game, and the world is going to be simulated enough to the point where things happen organically, and then you drive towards the end condition of the game, and then you yeah, then you can keep replaying it over and over again, basically. I've got a design document on the repo, so for people who have access to the code, It's in the documents folder if you want to know, like, there's tons of stuff in there, like, um, about, like, it's going to be like a turn-based, but kind of like every time you take a step, some portion of time actually happens. Um, and yeah, there's a lot more information in there about like the story and all of that in the design doc. Um, so now the story is based on gameplay, so it's quest driven. Um, it's purely driven by gameplay. There's a there's a story at the beginning. That's probably hang on a minute. Yeah, there's an initial story at the beginning, but then it's procedurally generated before you play. And then you'll pick up everything that happens in the world is due to the rules of the simulation. And then as you'll play yeah, I'm not sure I described it exactly too well. But yeah, there's no hard coded anything to do with the story when you play the game. It's all like organic through the gameplay systems. That's what I want to try and do. That's the initial thing I want to make. But we'll see where I'll end up after the graphics R&D. I need to have a rethink over it. Then how do you have story elements if everything is random? Um, because it's all I want to try and make it where it's simulated enough to the point where things organically happen through gameplay systems, right? It'll be a pain to debug, but yeah, obviously I do hate myself. Obviously. Yeah, the basics. Yeah. So there's a basic start condition and there's an end condition, and the rest is all in between. I personally hate the term RPG nowadays. It sort of means nothing. The new God of War RPG. Yeah, yeah. RPG is basically yeah. Those games being RPGs is weird. This is going to be RPG in terms of like you have stats, you make a character, or maybe you don't make. Yeah, maybe you make a character. I'm not quite sure on that, but you have a character with a certain set of stats. Maybe you get given those based on the randomness, um, but you've actually got like attributes and things and that you work towards and level up. Um, and it is a turn-based game like the original RPGs that you played. Um, but it's kind of got a bit of a spin where there's a given time that every time you move, time advances. Um, and this, yeah, it's very strange. The RPG terminology, that's for sure. It's a bit like the word roguelike as well. It just sort of gets taken and get used into nothing. Like that's why this game I've got, right, you could probably class it as a modern day roguelike, but I don't want to do that because it's just again just meaningless. But it's definitely an RPG. Like it's got the procedural generation. It's not got the permadeath, but people don't really have permadeath in anymore. Um, most yeah, it's grid based. Whatever roguelike elements are there in there, but yeah, I'm not going to call it that because it's not really a roguelike. Yeah, roguelite. Yeah. And then there's traditional roguelike. Yeah, so what people say roguelite is what most roguelikes. Yeah. People say most what people call their own game a roguelike are actually roguelites. That's what they're saying at. But yeah. I think those people ended up losing the battle and now they just call their games traditional roguelikes, basically. But yeah. I haven't lost the enthusiasm about the game yet. Like, I wrote it up in February, and I still think it's a good idea as time has gone on. Although I do think some things of it, a few of the core things need considerable thought still and solving problems. It's still an initial sketch of a game design, that is for sure. But yeah. So we need to make this go. GPU, UI, image. So the reason why I have this image ID is so I basically don't have to pass in tons of parameters every time I make an image. And a lot of the time you're going to reuse the same image, I guess. That's been my thinking. We'll see how true it turns out at the end. So I guess we'll just initialize the whole resource. We'll see. We'll see about that. All right. See how this goes. Look, let's skip over the definitions because there's no in hell we. Yeah, we can have agree what they mean. I think. Wait, what's going on? Yeah, I think what people do nowadays is they say this game is like game A and game B. And I think that's what people typically just try and do. And don't really stick to genres. Yeah. Ah. So if you try and also, do you want to display the surface? Because I'm writing to it while reading from it, I think. Wait. No, I read from it before it's been written to. Wait. No, no, no. It would have been written. No, no, no. We can't display the surface. What am I talking about? Wait. Where's something sensible? Alright, here's the occlusion texture. This is good. So in the lower left, we're seeing the occlusion texture. The colors are dead off though. We should probably fully set the opacity to 1. You got a bit funny there. But also we are viewing... Oh. I think that's a bit of an issue there. Right. We're seeing something now at least. The green and red like unset. Like in that case... Oh no. That's a depth value. That's a depth value. So it's just an integer in that case. Yeah. That's not sensible. But anyway, hard code it to 1 there. For now. That's fine. That's fine. Right, so the surface is upside down. Right, tons of great things going on here. We're also not viewing... and this layer... You can go out of bounds. I just realized we can go out of bounds. There's so many issues with this. Oh, that layers ain't sorted out there either. Damn it. Right. So we should start by only viewing up the portion of the texture which is actually visible. So we're copying it to the bottom left. Thank you. I'll take that as a compliment. Yeah, basically we don't care about the looks at the moment. So we're just putting stuff on the screen. We just care about functionality for now. All that matters. Appreciate it, though. It could be beneficial to think about terminology because then you find a lot of discrepancies in people's definitions, which results in deeper understanding of each game. Touched by the terminology. Yeah, well, you want to go with what the always in the zeitgeist, right? What is the general meaning of this word, even if it is technically wrong and people are dumb? You want to go with just what in general what is meant by that word when people say it. Like RPG is a weird one because a lot of people, when you say RPG, they think like, you know, someone who's traditionally grew up with RPGs is like stats, typically turn-based, but doesn't have to be. But there's a lot of emphasis on the attributes and probably making your own maybe making your own character as well. Yeah. Thank you, Hacker Man Mojo. Hacker Man Majo, thank you so much. Yeah, of course, but for a term to have meaning, you must have some confidence that most, if not all people, use it the same way. For example, as a physicist, if I say mass, there is near zero ambiguity. Right. Yeah, well, just look at the word roguelike. You know, again, it just is very ambiguous. It probably just means proc gen nowadays. And you can play it over and over again. Hey VMT, how you doing? How's it going? We got some textures viewing, but they're kind of weird. Right, so how do I... yeah, so we should probably just clear the texture, right? Just. Yes, we should probably just clear the texture. Where do we do that again? Dispatch copy. So here we want to go, oh yeah. GPU command memset or texture clear. Texture clear, GPU texture, copy resource ID. There's a clear value, texture clear value. And 0 is the way. Oh, maybe not 0. Maybe. 0. Wait. How's this even gonna work? How does that even work? So you poke in the clear value. It's not integers though, because this is a union as well. Right. Okay, so the underlying thing will be a U32. So maybe... Oh, shoot. I realize that. So maybe we'll just do 0. Let's just do that for now. So there's only an R component in the base tech. I think. Alright, let's try that out. So now we should have a cleared texture at least. Alright. Neat. So this needs to be... So we need to make sure we're only displaying... I guess we could just offset it now. We could put some offset. Yeah, because we're doing the whole box. Right, so... Man, how does this thing work? Right, there's an object pool allocate thing. I guess every time... this is weird. So I guess every frame we should just initialize a new one. And then just say, oh, it's a... The music's gone. Right, so I guess we just create one of these every frame. It's a bit annoying. But it should be possible. So every time we set the res ID, we just initialize this thing properly. I think this is the way. So with some UV coordinate. Now, how do we... So the UV... So the bottom left UV would just be 0, and then there's a UV size. So to calculate the UV, the size of the texture in UV space, this is going to be... Also, I didn't usually like that word. Size. I could just manually draw it. I can just manually draw it. And how is there a sampler passed in, but I never pass one in? Oh, it's a style. Right. Linear or nearest. Okay, good. So, right, maybe doing this whole thing is just a bit silly, because we could just we might just be able to draw it directly in there. That would be interesting. All right. So maybe let's give this a go instead. Where's the UI? Right, let's just initialize it there every time for a second. But let's not use the image. Let's just use the draw function. Right. So we're going to draw... Yeah, but then you have to put a shape down. Maybe this is the way. Oh, it's all in here. Sweet. So we need to get our rectangle. So let's get our rectangle. We call it R. And then we compute our command space ABB. So we just put in the half dimensions of R. We don't want any radius. Right. Then we put a texture in here. So that'll just be tab resource ID. Then a sampler. So we want to put the nearest sampler, no linear sampler, if not it looks blurry. And I might as well be using the zoom in tool, right? Which we're not doing. Right, I don't have a nearest sampler in here. This sucks. Crap. Damn abstractions. No. Maybe we can have some built-in. Alright, we'll sort this one out. GGP, it'll be in there. Then we need to put it... do an offset from the bottom left. And then the size. So... UV dims. The size of the UV is going to be... so I need to figure out the resolution of the texture. So I think we've already got it at resource. It could be based on some MIP level as well. Yes, you have to slide it down by the MIP, probably. Have we got a resource here? No. Just saw we did. Oh, right, we should get this. Alright. Here we go. So, for crying out loud. Right. So resource texture dims .xy float 32 times 2 cast, and then that needs to be divided by how close is it to the maximum supported resolution, which is the dimensions of the copied destination, or the texture viewer copy texture. So that should be what we need there. So only view what we, although this is, we should be drawing in the middle. Yeah, this is going to be really big. Yeah, this is going to cover the whole screen, by the way. For now. But yeah, maybe we can change the size of this half dimensions. Maybe we can set it to a pixel perfect for now. View dims. Yeah, view dims and view offset will make, I think. So we'll just say, oh, it's equal to the dimensions of the texture. And that'll be a good start. And then maybe you want maybe you have some view offset as well. That will change when you move the mouse. So we've got to get this clamp nearest sampler sorted out. Bit annoying. So yeah, I think we at least want these two probably in the GPU backend. Alright, GFX internal. Grab those boys and girls, put them in there. Oh. Alright, so I don't think we need this anymore. That'd be interesting. See, I think the UI is not going to want to work anymore. Oh, these aren't going to want to work. Right, that's where we use the samplers, I think. And in the UI, obviously. Alright, it's compiling. So let's see how this works. No. Segfault. Right. Okay. So these new resource IDs take up a... Yeah. They get in the way. But Montana, thank you so much for sub. How you doing? Communion, how are things? 30 months, wow. Incredible. Yeah, things are pretty good. We're just working on texture right now. Taking a break from doing the 3D rendering for a bit just to make debugging a bit better. But yeah, things are going good. Yeah, personal life is going great. The baby boy's good. Family's good. Yeah, how's things with you? I appreciate you asking. I just started doing some YouTube videos again as well. So kinda making devlogs now. Where we're recapping the streams. So yeah, hopefully the content will be more digestible than the streams for people who are going to miss them, which is nice. Busy work, man. Having a rough time, but we'll get through it. Yeah, that sucks, man. Well, I hope you find your way through it soon. You yeah, I guess you just got like a lot of things to do at work, lots of responsibility, perhaps. Right, so initialize the GPU system in here. No, we initialize it. All right. So after we've initialized this and done our hard-coded resource IDs, then we'll initialize the samplers. It is a bit of a hack, what I've just done here, but this is the way. Yeah, it's alright. We just need it working. So they're in there now, in the GPU backend. Right, so click on a texture. Okay, I was expecting to see that in the middle still. But yeah, we're not seeing... Why is it so small? Oh shoot, I still put that down, isn't it? Still put the old one down. Ah, excellent. This is good. No. So it was drawing it. I don't know why. Right, let's retake a look into that image. Let's delete this image. Bad ideas. Alright. So I want to look into how the image works. So an image draw, when does that happen? Image get, then a draw. Right, based on some rectangle. Alright, so I think should be alright then. I guess the input parameters are a bit off. Something's weird with it at least. Right, we're displaying the texture. Well, Wally, we should be here displaying the texture copy. Rather, one that we've copied. Oh yeah, right. Things are coming together now. Okay, so now the size of the texture is obviously just a little bit too big. Now, what have I done since that last recap? I've I don't think I talked about the dispatch. Yeah, I haven't talked about this yet. Okay, this is fine. So I got to talk about this and the UI changes as well. Okay. Maybe I could do this separately. Always good to catch up. You working on GPU stuff? Yeah. Yeah, working on some GPU stuff. Probably will be for another year maybe until we're done, I reckon. So I can move off of it. A project under pressure work will be the situation until somewhere in summer. Right. Well, it's not super long. Yeah, still though, day by day it feels long, I can imagine. Yeah. Well, I hope you get relinquished of some of that sooner. Yeah. It's always stressful times are not good. Uh, but yeah. Um. Hmm. Yeah. So we're making this texture viewer because it's been like so fiddly just trying to take a screenshot and compare pixels on the screen. So we're going to be building this a way to take screenshots and view them in the texture viewer, but also make it so we can debug some textures a lot easier rather than opening up render doc. So it's kind of like killing two birds with one stone, basically. So it should be cool. Do you still do a lot of work with the Vulkan in the Vulkan layer? I haven't popped back in there for a while. It's all abstracted away, and it has been for a while. I don't. Yeah, I know there is a bug to do with the synchronization of the upload and readback stuff, but it's not bit me in the butt yet, so I've not fixed it. But yeah, it's very minimal, so it doesn't really need much catering to. Um, Although there's something with these frame times bouncing all over the place when you're looking at objects. So I need to look into that. Maybe it's something to do with sync code. Yeah. It even happens when we're not streaming, so it's not OBS. Oh, it could be we're uploading massive buffers. Maybe. Yeah. I don't know what it is. Yeah, they sort of bounce all over the place every other frame. Especially when there's a lot of work down. Well, these are solidly 10 milliseconds for some reason. But yeah, usually they bounce between 8 and 10 sometimes. Bit weird. Yeah, something's wrong. I need to find it. So what should we do now? Maybe we hard code this to like. Well, you really got to keep the. Let's half it. This is still way too big. No, it can't be. Huh? There we go. What's that 0.1? What is resource in this case? It'd be that. You got 10 of those until it... I guess so. Right, let's make it a quarter the size. That'd be right. Yes, I guess we should recap some of this stuff now. Let's do a recap because it's a bit much. So we've got the dispatch copy. I've had to make the change in the shader to make them always show alpha pixels. Yeah, this is BGRA. It's kind of flipped the wrong way, and it's flipped upside down. Yeah, so we've got a problem with like upside down textures, and yeah, there's a lot of things to fix up here, but at least we're seeing something. Let's talk about that. Let's put a marker down. All right, so what we're going to do is we made this GPU texture viewer dispatch copy. So it's going to dispatch that compute shader we saw earlier from the CPU side. So what it is, we clear the whole texture since there's going to be some parts of it which are going to be uninitialized, so or from previous copies. And then we get the currently selected tab, and if there's no resource, we just return. Or no selected resource for this tab, we just return. And then we get the currently selected resource. We initialize all these parameters we saw earlier, like the resource index, the text, the resource type, the MIP levels, the dimensions, the currently selected MIP we want to view, and the array layer that we want to view. Then based on the resource type, we fill in the array layers a bit differently. So 3D uses the dims.z, whereas the texture 2D and the 2D array use the array layer. And then we do some synchronization code. So we read only from the texture we want to copy from, the one we want to view. And then we read write into the texture viewer copy texture. And we dispatch the shader. So from there, we had to change in the texture viewer as well, we have to probably make the color alpha fully opaque. But yeah, when we reinterpret some of these pixels, I've noticed actually when we view the depth buffer, it's just a 32-bit integer, which actually ends up being a floating point. Reinterpret costs into a floating point 32-bit. So we kind of just overwrite this is just, so it just looks a bit weird, but yeah, we'll see that in just 1 second. So yeah, in the UI code, all we did is where we do that split area now. So here's the left-hand side box. After that, with all the attributes and stuff, there is a right-hand side box. We get the rectangle for that. We calculate the UV dims. So this would be from 0 to 1, where the 1 means the maximum texture size, which is the size of the copy texture, and then this is the size of the resource. So we divide the size of the resource, which is always going to be smaller than or equal to the maximum texture size. This will give us a nice value between 0 and 1. And we need this for when we draw the texture. And we've also got the sort of view dimensions on how big we want it to be on the actual screen. So we've just hard coded it to be a quarter of the size for now. Then we're saying so we haven't used the UI image widget. We've just got into the draw API code. So we're just saying, hey, we're drawing a bounding box with the local space size being this. Well, this is the half dimensions actually. This is the reason why it's a bit weird, why it's too big. This is half dims. Okay, right. Then we say, hey, we're gonna color in this shape with a texture. So we give it the copy texture here, not the resource texture that we want to view, the copy texture. And then the clamp nearest sampler, because we want to make sure that we are seeing each pixel and it doesn't get smudged. And then we put the dims in here to say, hey, we don't want to view all the stuff that's off the edge of this texture that we've copied into that temporary to this copy texture. And then we finish the draw command by giving it some screen space center position, and then that will draw onto the screen within the clipping bounds of this box here. So one thing I did actually forget to mention before we run is, for now, at the end of, so when we submit a frame submit, we call that dispatch copy for that texture viewer. But we obviously want to insert this directly after when the resource has been written. But for now, we just put it at the end of the frame because we know there will be something in there at least. So if we give that a run, hit F9, and then we're going to view like the occlusion texture, and this is what it looks like. Again, we're seeing some floating point number with a hard-coded that's then turned into RGBA and then hard-coded alpha. So it looks a bit wrong, but at least it's the start to something. We still want to add some controls where we can sort of move this around the screen and zoom in and zoom out. But it's a nice start. So, yeah. Can you show how to swap endianness of an in C++? What? There's a function called, if you look for bswap, look for bswap Sully. You can make your own, but if you look for an implementation of bswap, that's what I usually call it. It's on Linux, it's called bswap. You can just use these if you're on a Unix system, I think. Maybe Linux only. Oh, GNU. On a GNU system. If not, you can just roll your own. They're quite simple. You just gotta change the bytes around, right? You mask the bit at the front, it goes at the back, and and the second byte goes in the third position and all that, right? They're quite simple. I'm sure you got this. Right. What else can we get done before the end of stream? So that's kind of nice. Should we get some zooming in, moving around, something like that? So these should probably be globally accessible in the texture viewer. Yeah, so we want some kind of like offset and some kind of like, do you call it zoom? I think you do, right? Or scale, yeah, or whatever, right? So you have some offset, view offset, view scale. All right, so got those in there. So the view offset. Okay. So add float 32 times 2 GPU texture viewer dot view offset, right? That's nice. Then the other one is this sort of view half dim. So the way you calculate this is you take the texture size, you half it, and then you multiply it by some scale as well. So since it's multipliers, you can just chain them in any order, and it's okay. So you say texture viewer dot view scale. Now we're just gonna hook up some controls, and then it's as easy as that. So the controls would be like, so you want to know if I'm inside this box, So you kind of make the box focusable. And then, because if you drag and go outside the box, you know, it might not be so much of a problem. But yeah, if it like contains point. Yeah, this one. So yeah, so it's kind of not correct 100%, but should be good enough. So we get the mouse position. All right. So if R contains point, and OS virtual mouse button is pressed, we're looking for the OS mouse button of the left, right? Then we want to take the relative mouse position and GPU texture view view offset equals plus equal OS virtual mouse relative position .x, and do a Y version as well, right? So that's cool. There's also the zoom thing as well. So if OS virtual mouse relative wheel position .y, so if that is not 0, we then want to take that and then change the scale by some increment. So this casts it into a float and then multiplied by some, like, I don't know, 0.1 or something. So have a look at that. Hey, Renny Goblin, how you doing? C++ adds byte swap. Oh no. C++ 23, the bleeding edge, as you're on it, right? Oh, it's a single instruction on x64, fair play. Oh, yeah, I think I remember that actually. Yeah, texture viewer, this is the way. It looks damn ugly, but this is the way. Right, I'm not seeing anything anymore. And that's because the scale defaults to 0. Bum, bum, bum. So unfortunately we're not 0 initialized here. But that's okay. Nearest tabs count. Rightio, let's run that. Yeah. So we zoom. Look at that, got some zoom in. And I'm dragging. If I go off the screen, it stops. Kind of annoying, right? If we have that problem, but I don't think we do, right? So this is okay. Right, I like that. I like that a lot. But there was a thing I wanted to fix. Yes, this clamp scale has to be within a sensible range. So we want to say clamp between not 0.1 and I don't know, 8. Is that too much? Good. Updated my game yesterday and got some snazzy day and night cycle created. Ooh, nice. Day and nights. Awesome. You got a video. Let's go zoom. It stops there. Pretty reasonable. So really, we want to be able to zoom until we're seeing a pixel. Wait, no, sorry. Take that back. I was about to say like actual pixel size, but that would be like all the way back here. That's done. Yeah, we're gonna be able to keep zooming in for a bit, but maybe that's too slow. So maybe this should be 0.2. I think twice as fast on the zoom. Do you care seeing it like this, in all honesty? How does this help? Maybe the min texture size should just be 1. Like, texture scale should just be 1. So then this could probably go up to about a quarter of a texture. So it takes you 4 to double the size, or to increase it by another 1. Yeah, that's better. That's better. That's good. So we move that around. Or maybe, maybe we can allow it to go 0.5. Because it might be a bit too big. Right, that's good. That's good. Cool. Yeah, occlusion buffer. It's not being viewed too great though. We've not got a good reinterpreting of pixels yet. There's something to do next. The reinterpretation of pixels is just wrong. Yeah, it's but we're seeing something, so it's good enough to get some of the controls in. I'm also still moving the camera while I'm but yeah, it's all right. But yeah, I've got the layers and MIP levels to get sorted out, but it's come a long while. Yeah, so let's recap this. What did I do? I just added why am I doing this thing? Because there isn't a nice easy way to take a screenshot and view it. So it's going to be integrated into this tool. So I'll be able to take a screenshot, it'll copy it to a texture, and then I'll be able to view it. And more so, I'll be able to view textures at different points in time. So it's just doing like a killing two birds with one stone, being able to debug textures that I've written to, basically. So it's going to be pretty useful. But yeah, so the main thing I want to use is this screenshot. So I press a button, opens it up in a new tab, and then I press the screenshot button again, opens that up in a new tab, and I can toggle between them and compare pixels rather than open up into Krita or open up in RenderDoc and comparing two captures. So that's just a lot more. It's very fiddly every time I do that, and it's very error prone at the same time. Whereas this would be less error prone, and it would be just kind of instant. So it'd be really nice. But also have the extended ability to actually view how textures change throughout the frame as well. So yeah, kind of just getting debug tooling improved. What's the PSNR? Peak to signal noise ratio. Huh. Is that what you mean? Right, I need to recap what's gone on. Yeah. No, I don't need the compare. Oh, that's another thing we could do. Do a diff and view a diff of two images. That could be an option. I don't know if that would be. I just want to be able to tab between the two and see the changes myself. Maybe if you, having a pixel diff is not beneficial. But yeah, it's an interesting thought. I'll jot it down. We'll have a think about it. That it does sound interesting. Yeah, it's usually what you'd use something like that for. It's common for texture compression, compressing a G buffer, color conversions. Uh, is it what you'd use it for? Yeah, you'll be able to view the packed data in a different way. You'll be able to, in our shader, we're making this thing where when you read the pixel out, you can basically reinterpret. We'll have some if statements where we can reinterpret it. So if we had a G buffer, for instance, we could take the individual components out and only view like the normal or something like that. So there'll be ways to custom view things as well. But I don't think we're going to have a G buffer. But yeah, if we did. But yeah, we'll have one for like a view in depth and stuff like that. So yeah, it's going to be good. Gonna be good. Right, let me recap this. Okay, so what we've gone and done now, we've gone and added the ability to zoom in and offset the texture. So we load up the depth texture, for instance. We can now move it around. We can zoom out, right? And we can zoom in. So this is, yeah, this is super. It's gonna be super helpful, obviously, going forward. Oh, that is not handy. That's right. Okay. Yeah, that needs to get corrected. All right, we're not doing this one. Right, so we do the offset. We need to move it back to the middle. Wait. When we scale, when you zoom in, you're making the texture bigger. So you need to make sure the offset is also scaled by the difference, right? So this is your scale diff. So you need to get like the old scale. And you need to do a scale diff. And then you need to offset it by scale offset by, so it'll be 1 plus going towards the new scale from the old scale. And then I think you just multiply equal that. Wait, multiply equal this by scale offset by. I think that's right. If I remember correctly, that's the logic. It's moving a bit wrong. Are you creating foundations for cinematic rendering? What do you mean by that? I was thinking about my pipeline to DXT 5 channel packed normal roughness metallic. Right, you mean like PBR? Is that what you mean? Like physically based rendering? Oh, what's going on here? So if I increase it by a quarter, we're going to multiply the offset by maybe half a quarter. Ah, shoot, did that wrong. Wait. That... Yeah, I guess I need the parentheses, but yeah. I think that's right now. Why does it just go bananas? Oh, maybe that isn't right then. So you need to move the view. Maybe you need to move it back to center, scale it, and then put it back. But what does that even mean? Because it's relative from the center anyway. So if you've got an offset of like 25, or let's just say you've got an offset of 8, you increase it by a quarter. A quarter of the resolution of the image. So you need to get, okay. So you need to get the size of the texture. I think it's something like that. So you're adding. Is it just the difference now? Yeah, no 1 plus. Still way off. Alright, only goes in one direction now. That's not good. Yeah, we need to go in the direction of the... Need to copy sign. Shoot. Hmm. Well, a lot of features you're doing could be used for cinematic rendering foundations if you want that's in direction with your raycast, etc. I'm curious what you're doing performs a realistic scene thrown over it. Right. Yeah, I can imagine. I don't know if my brain would be capable of be any better, to be fair. But yeah, I don't know. I'm looking at doing some kind of PBR, physically based rendering, and doing some probably somewhat physically correct lighting. But I don't. Yeah, I think we'll do that because I haven't done PBR before, and we get to learn it. And it seems just the way most games typically go anyway. But I don't know if I'll have a realistic renderer though. I just want to probably have realistic-ish lighting, if you will, because it looks nice. But maybe we might, yeah, I'll never play with that at least. So there will be roughness, metalness, and all that. But yeah, we'll be doing that after this texture viewer actually. Going towards a new scale from that one. Oh, it's the half of that, isn't it? I think that's right. Right, messed that up. So, think about it again. So you've got an offset of 8 pixels. You zoom in by a quarter. So you up the scale by a quarter. Then you take the quarter of the texture. So you up by a quarter, save your 8 pixels in, save your texture 16 pixels. You've increased it by a quarter, so a quarter of 16 is 4. So you have increased it to 20 pixels, right? So you're halfway through. So you need to go from 8 pixels to 10. So that would be a quarter of 8 and then a half. Wait. So it's a quarter of the current offset. No, but we tried that, didn't we? No, I did 1 plus. Wait. No, it's plus equal. I'm using cheap PBR. It's hard to achieve in shader unless you're doing wavelengths, source light energy, etc. Yeah, I think I might be doing what you're doing. At least at the start, that's for sure. Oh, but it just messes up the... Does that? It's weird. Right, but then actually do another quarter. So you did... It's a quarter of the... So that's 1/2. Right, so maybe the easiest way is to... It's probably not the most efficient. But you scale it back. And then... Oh, okay. And then scale it back up again. Yeah, that's probably the way. Doing this diff is probably a bit wrong. Yeah, it's just gonna be a bit wrong. So maybe we just divide by the old scale. Maybe this is the way. Divide by the old scale. Multiply by the new scale. It's probably that easy. Is that right? Okay, that's in the middle. That's obviously going to work. Right, seems alright. Excellent. So now the zoom is centered around the camera. Right, that was much harder than it's supposed to be. Let's build this Milton. Or build Milton into it. I was thinking about that, doing a drawing tool on top. I generally did think about that. The issue with it, and I use Milton here. I use it, right? You've seen me draw. Horribly, probably. But you've seen me do drawing, right? Well, you do use Milton. It's a great tool. Can you insert images into it? I don't think you can. But yeah, I've considered drawing on here. Because it's maybe useful to be like, oh yeah, and then color over it. But the issue with that is I would need to do undo. And it just takes time. Like, you could probably remember all the edits and have a separate texture maybe and then apply it on top. But yeah, it just takes time and I'm not sure how useful it would be. Plus, you'll be drawing whole pixels, I don't know. Stack for undo done. It's not that simple because you got to apply it to the texture. Like, if you're drawing on it, right? Do you, every time you change it, do you reapply all the drawing on top? Maybe. Maybe we can do it. It might be useful to draw over it. But we'll see. Right, I'll just recap this, and then we'll yeah, just recap this. Alright, so we've added the ability now to offset the texture and zoom in and out. Well, we just zoomed out, but yeah, centered around where the camera currently is. And yeah, it's got some minimum and maximum range, but this is basically a killer feature that we're going to need. But yeah, let's quickly take a look at the code, what we've done. So we've basically just added these global variables called view offset and view scale. View scale is initialized to 1, whereas view offset is initialized to 0. So we've just done it right in where we have that sort of right split panel, right where we draw the image, which we just went over earlier. And we're saying if the mouse position is within the canvas, if the mouse button is pressed, apply the relative position to the offset. And then if the mouse wheel has changed, then we get the old scale. We offset the current scale by a quarter of the mouse wheel movement, and then we clamp it, and then we divide the view offset by the old scale and scale it by the new scale, and that helps us do this centered zoom around the center basically. So yeah, that's all pretty nice. It's a nice feature to have. Right, it's a good recap. Good enough. Yeah, maybe I could do the drawing. I'll jot it down. Right, we'll have a think about it. Maybe allow drawing over the texture. Right. You have color selectors as well, though. Yeah, there's things to add. Maybe it could just be inverted, but then inverted looks ugly. Typing text. Why don't I type text? Why don't I want to type text? Okay. It's a bit. I don't know why it solves too much. But yeah, I'll tell you what I've thought about as well. I've thought about a GIF exporter as well, because that one would also be handy, is putting a GIF exporter in, because it wouldn't be too much more work after a screenshot tool. But yeah, I don't know if I need it yet, so I might do the GIF tool later. But the GIF tool will be pretty good. You'll be able to start it with like Shift F12 or something, capture your GIF, and then it'll show you all the frames, and you'll be able to cut the beginning and end off, and then press save. It just saves out to disk. It shouldn't be too bad. The GIF tool will be quite good later on. That's for sure. I have a hey Sockham, how's it going? A redundant but raw approximation for metallic reflectance in my shader. It's like a few mults and adds in the formula, but it lands the rendered image in a range. I need to do research to make things next level Disney cinematic photorealism levels. Cool. Awesome. Copy paste PDF. What? Network collaboration. This is way too many features. Way too many features. Right. I need to recap and then jam. I need to jam. Right, let me do some in here. Gonna be good. Oh yeah. Hello, what? Hello everybody, welcome to another Game Without Engine devlog video. So today we're covering day 111, and we've gone over the custom texture viewer part 2, where we implement viewing the texture and other little bells and whistles as well. So before we get into that, here's all these lovely links. It's got the Twitch timetable, we've got the VOD channel if you want to see the full stream, be available there. There's a Discord. You can come and hang out and chat some more outside the devlog. You know what? I know what I gotta say. It could be smoother. One more time. Hello everyone, welcome to another game of words. Alright. Yeah, YouTube, that's right. So we're taking every stream, making it into a devlog, recapping the whole thing. I hope to try and edit it after every stream, but yeah, I don't know if I've got the time tonight because I overwent. But yeah, it'll go up. I just have to get some time tomorrow or something, sort of quickly throw it together. But yeah, I've just got it all marked. I'll get the video, chop it all up, and put it up. So we do recaps now. That's the plan. I just started it last video. The hardest part of the PBR, in your opinion, is the calibration of your material system. What do you mean exactly, calibration of the material system? Curious about that. Right, another marker. Hello everyone, welcome to another Game Without an Engine devlog video. So today we're covering day 111, and we're going over the custom texture viewer part 2, where we basically add the ability to offset the texture. Wait a minute, offset texture, I've just done that. What is going on? These words are on time. If not, I'll just do it in the future. Hello everyone, welcome to another Game Without an Engine devlog video. This is not going to work. I've failed too many times in a row and it's late and I'm tired. This is fun. I'll just do it when I edit the video, when my brain has been refreshed and I haven't messed up more than once. Right, let's find someone to raid. That recap, I don't need to recap, I just need to do an intro, because we basically recap throughout the stream. It's good. But yeah, bedtime for me. But yeah, our next be on guys, Thursday, 7:30 p.m. GMT +1. Sunday, 6 o'clock GMT +1. Why is there no one on? Is there someone on? Time to train an AI to do the intro for me. Maybe that's the way. Hey Ross Musco, how you doing? Do you want to see a quick what we've done today? So we did this yesterday, right? Where you can view the textures. See the list of textures. Today we've got this left panel with a bunch of information. Again, very, very beautiful. We can view the texture, zoom in and out, and move it around. But yeah, the way we're interpreting the pixels is really bad. That needs to be sorted out. But yeah, good progress. We'll be basically improving the reinterpreting of pixels and viewing different MIP levels and array layers. Next stream. Yeah, I hope you're doing well, Ross Musco. Well, once you have your rendering pipeline where you want it, you have to adjust your materials or PBR channels based on dielectrics or conductivity formulas, or simplify your rendering, etc. Oh. Once you have your rendering pipeline where you want it, you have to... Right. I thought that's the whole point of metalness and roughness. Right, yeah, so your metalness is saying how not dielectric you are, right? So the more closer you are to 1, the more metal you are, the more closer to 0 you are, the more dielectric you are. And then you've got roughness, which determines how smooth the material is or not, right? That's my understanding, at least. So what you're saying is you have to make good materials based on those two parameters, right? Because all the other stuff is just maths in the shader, right? Yeah, I've not done it before, but it's just from understanding. But yeah, something we want to cover in the future after this texture viewer is doing PBR and just seeing what it's all about. Right, let's rate this Jai guy. Jai guy. But yeah, check out the links, guys. Check out the Discord. If you want to get access to the code, you can also, it's on there as well. Crying out loud. Yeah. Yeah. If you support the channel, you get access to the code. And thank you to everyone who's supporting the channel. And why is Leo in my browser? Go away. Huh? It's reading my screen. I told it to go away and it's just reading my... It's answering all the questions. What is going on? It gave you a B-swap answer. What? Very subtle shifts depending on your lighting contributions, formulas, speculars, etc. Oh, okay. Right. Okay. Right. Yeah. I get you. I think I understand you, but yeah, thank you for coming, everyone. I'll see you on a future one. I'm gonna, gonna go and crash and sleep. But yeah, enjoy the rest of your evening. I'll see you in a future.